So I don't like the last example where the function we're trying to optimize was given to me. So like my first question, let's go ahead and take a peek at an example where I have to create the function I'm trying to optimize on my own. Now, certainly the total area that I'm trying to maximize is the area of some rectangular region plus the area of a semicircle, where that area is computed as length times width for the rectangle. And for the circle, it's going to be pi halves times the radius squared, but the radius is just half of x. And I don't like it. I'm in a bit of trouble. I'm in a bit of trouble because technically speaking, the area is not expressed as a function in a single variable. Now, if you give me a couple of semesters when we study multivariable calculus, I can deal with this. But for now, I need this right-hand side to express it as an expression in a single variable. So it's time to stop, panic, look at the problem situation, and see if we can't find some kind of constraint relationship between x and y so I can solve for, say in this example, y in terms of x, make a substitution to get the area as a function single variable for which I can apply my current tools of calculus. And looking at the problem situation, the only other constraint I have is a perimeter, which is computed by, if I plant my feet here, y plus x plus y plus half the circumference. But the perimeter is 15. Meaning y is this. I'll make a substitution. Y is that. Lost my x. So has it shown up on the board? Okay, decent enough. Now, cleaning up. Can I get rid of this? Now that I express the area as a function of a single variable x, let me clean up so that I can differentiate conveniently. So here's my critical number. So can we just stall for a minute just to check our number sense, see if this answer even makes sense? If pi is 3, if I approximate 30 with 28, I get 20 over 7, which is 4. The perimeter is 15, so it makes sense that that would be a decent or an appropriate value for x. I'm just trying to check my number sense, see if this answer makes sense. Now, building a sign graph. Let me go ahead and plot that only one single critical number. Go back to my derivative function here. If x is to the right of that, like, I know I'm being extreme, a billion. I know in the picture it can't be a billion, but if it were, that's negative. And if x were another extreme, which is unrealistic, like 0, the derivative function is positive, Looks to me like a change from being positive, negative about that critical number for the derivative function, which means the original function's optimized at that value. So with that sign graph I've just shown you, that by the first derivative test, x be equal to that value of 30 over pi plus 4 maximizes the area of this window. You know, technically speaking, I didn't answer the question because I asked with dimensions. I need to find y, but I erased the relationship x and y. I had to substitute big N for y if you want to come up with the other y value. I'm just trying to save time.